I apologize for any mispronunciation, Mr. Daniel Armando Di Guglielmo.
That was pretty good.
Okay. He's from Argentina, and he's representing his company Azteca. I'm not really sure how to say that either.
It's okay.
He's the director and teacher of Educational Robotics Institute, and he is going to present about taking advantage of recycled materials to create inventions.
Can I start?
Mm-hmm. Of course.
Okay, thank you. Good afternoon. Well, as I was already being presented, my name is Daniel Di Guglielmo, and we have in our country some characteristics, and we do not have an advantage of buying easily or at low prices different materials. As everybody must know, when you work with robotics, you use electronics and motors and sensors. Sometimes they get a little expensive. Now, even though they're not so expensive sometimes, there are no parts that we can buy here for specific works. So we have to bring them from outside, from other countries. And most times we have a lot of expenses in traveling and taxes. And even sometimes we don't get the package because they get lost usually in our customs here in Argentina. So my function now is try to teach people to use non-expensive materials. And we found that we have a lot of very nice and precise motors, sensors, and all those stuff we use in robotics but machines like printers or scanners or whatever that are already not in use. Most people throw them away, and they even are bringing some trouble to the planet, I suppose, because we have junkyards with a lot of electronic things. So I'm going to share with you a PowerPoint. I'll keep on talking while we see the PowerPoint. Let me see if it works. Jake taught me, so suppose I found out. Yes? On? Sure. Okay. Can you confirm me, please, if you're seeing a PowerPoint now? Jake, I lost your audio.
We can hear you.
Okay, thank you. Okay, this is me. The name of my institute is Azteca. I started it from scratch, and I'm director and also teach because I will never stop teaching robotics. What we're going to talk about is taking advantage of recycled materials to create inventions. Doesn't matter what kind of material, even wires. We can recycle wires that have plugs on the end, and we always can take advantage of that. And once again, I see people that are throwing tons of materials and machines away that we can recover at least partially. How to use some recycled materials and different ways in order to teach students from different levels. This is a new idea I started about 1 year ago, where I can get one, let's say, for example, a printer motor. They're very nice motors. And usually it's very difficult to program that motor. Some people don't know how to use it. So I prepare it, I program it, I leave it ready to be used by a small kid that doesn't know how to program. And that way the smaller kids can use it just connecting a battery or a switch or something simple. For the ones who understand, I'm talking about a brushless motor, very difficult to use if you don't know how to program. So next level would be to use the same motor, exactly the same motor, but probably with no electronics in it. So the next level of students should be able to create a circuit board with electronics in order to use the different coils on that motor. Again, all this is a little technique, but anyhow, excuse me. Excuse me. Okay, here we go. This is how I'm going to explain. This is something like a preliminary about the whole speech. I teach technology, for example, robotics. It's very much fun for children, especially because they do hands-on learning. It's all hands-on activities. So I get the students to learn very difficult, strange things just because they need it. But at the end, the students will be learning by playing. We do have a need of special materials, as I told you before, sensors, specific sensors, and motors, different power of motors, circuit boards, etc. And all that creates a very expensive situation. We cannot afford it, not only because of the money, but also because of the lack of the materials. Besides that, we do help to ecology because we do know the law of the 3 R's: reduce, reuse, and recycle. And that's exactly what we start doing now. If we find an electronic junkyard, a surplus, they're getting very popular nowadays in big countries. I've seen some pictures where you can see an incredible amount of tons of electronic trash. I don't know if you say that way, but they don't recycle it. They just, I don't know, they throw it somewhere. And it's a real pity because they are very high precision parts sometimes, most of the times. Sensors, motors, switches, axles, gears, screws, leads, heat sinks, and much more. So let me show you an example. This is mountain of printers. It's not mine, but it's very similar to the one I bought about 3 months ago. And it's very common to see these things nowadays, not only printers. Each one of those has literally hundreds and hundreds of different parts inside. I'm going to try to show that in my next video. Unassemble a printer, and there we go. I'll be talking while we see the video. I think it's possible. So you can see some. Excuse me, please. Okay. Now, that's a small, normal small laser printer, only black. So it's one of the most simplest printers. Here we find some LEDs already soldered on the board with some switches, very useful. I take them out usually with the cables and the connector, so it's easier to use in the future. A lot of screws, you can see that you're going to buy about 70, 80, or maybe 100 screws. We start getting, I'm going to show you the mouse here, some, well, in this case, it's a coil, and it's called, what's this? Contactor. Well, something like a relay, but it's not making a contact. It's pushing a mechanic piece using the force, magnetic force created by a coil. Then we can see much more gears around here, and we're going to see several parts like a motor and axles. Axles are very useful because they're very high precision axles. They use standard measures like 6 millimeters or 5 millimeters or 8, and they're very good steel. They're completely straight, very high quality, just because the printer itself has to be very high quality, very precise, and gives a nice and neat printout. That's a motor. That's a brushless motor. If I go to buy that motor outside on the street, it will cost me a lot. I don't know how much here in Argentina, but I would say about $10, $15, or maybe $20 in the States. Inside that board, we're going to see it afterwards, a little slower. There are different pieces that we can recover. Now we're touching the optical unit of the printer. We have a motor with a mirror in there that we're going to use for some project. And we also have a laser, the axle. That's the one I told you. And I think that's it. Yes, that's it. Now we're going to go through some pieces that we took out usually of the printer. I'm focusing only in the printer because this would be a longer video, and Jake told me that I could not go past the 20 minutes. Maybe 30 seconds, but not more than that. I remember that, Jake. We have a fan, that's called a cooler, different springs. We have only this one on the photograph. We have about 20 or 30, sometimes more, different sizes and shapes. You won't be able to buy that if you need it, but you can just go around your shop and look the one you're looking for. This is the magnet I told you before. It's a coil that it's magnetized, and it moves this piece up and down, creating some kind of a movement in your mechanism. That's another one, the same coil. And that's a printed board, probably a power supply with capacitors, heat sinks, transformers, a whole lot of things that we can take advantage of. That's the same one. Now we have metal pieces that also can be useful. I don't know specifically for what in this case. That's another motor, a little bigger. Depending on the printer, you're going to get a strong motor, not so strong, depend on your applications. By the way, Jake, I still have those stepper motors you gave me last time I was at your home. I used some of them, they're wonderful. I have a nice board. It has the 6 layers we saw at the beginning with 2 switches over here, and they're ready to connect through these cables. So you don't have even solder anything. Just add it to your project. That's a laser. Doesn't say much. It's very small, but when it works, it's a real laser and pretty strong. It's another motor with a mirror on it. It comes from the printer also. Well, a set of gears, all interconnected, 2 gears interconnected. These are optical sensors. They're used to create I don't remember the name. Well, anyhow, you have an infrared ray inside there, and when something goes across there, you'll detect it, and you can count the amount of turns or just detect a situation that is happening. So that's a sensor called, I don't remember, I'm sorry. These are hard disks. You can get mostly 2 things. The magnets are very strong magnets, neodymium magnets, and the motors over here. I don't know if these are the motors or top part of the motors, but anyhow, they also are brushless motors, pretty powerful and very, very precise. More magnets. These are a couple of pieces of a part of a printer, just showing how many things come out. I'm not going to describe all of them because it will be very long. This is sending a CD reader and reusing its parts. This is a disk drive, no, sorry, a DVD drive. Okay, and in the DVDs, we have a special part, very important for me. There are the axles. Here you can see 1 axle, where there's going to be another one from the disk drive over here that has like a spiral. That's very useful. It's connected to a stepper motor. So besides the stepper motor is precise, we also have this spinning here that helps the precision. And it has to be very precise because the disk drive, to be read, has to have very, very precise movements and very, very small travel, very short travel. Thank you. This is a laser that's done, power supply with both things inside. This is just a photo of a partially unassembled printer, a lot of pieces in a box, including a stepper motor on the right side over here. Okay, and a lot of pieces of different printers. Again, here you have some rods from probably a matrix printer, and also the rods are very useful, especially the ones come from scanners that are long, because we can make a CNC. That we're working now on some CNCs, and you're going to see now as an example. Well, here are a whole lot of gears also. All pieces come out from a printer. Matching gears, springs, matching gears, more springs and gears. Now here you have CNC or plotter, whatever it's called. In order to build a big one, we need powerful motors. For example, a motor from the printers. But we're going to see now an example where we use small motors. Not this one. Well, we still are with the printers. This is a power supply from a printer. I'm sorry. This is recovering fans. Well, we actually use this because we're people soldering, and as everybody knows, it's pretty toxic to solder. So we built some kind of big fan, built up by 16 small fans, coolers from computers. This is the first example we're going to see complete. It's a 3D printer made by a coffee machine. You have several motors lifting here, all programmed. I did not do this project. It's not one of my students' project, but it looks pretty interesting. I never saw it working. I would like to see it. But anyhow, somebody is trying to design something with reused pieces. This is a plotter. It's pretty neat. It's a big plotter. We have the big long rods, probably from a scanner. And we're not doing all these. We're doing small ones we're going to see in a minute. But anyhow, it's the same concept. We have an XY, XY and Z, XY and Z over here in order to pick up a pen, put it down and make drawings or put a laser in it or whatever you want to do. This is a little bigger one. It includes Lego pieces. This is with all reused materials also. It's a toy. We have another plotter. And now we have a plotter made with the old disk drives. The old 5 1/4 disk drive. You'll have pretty powerful motor and a longer travel in order to have a bigger plotter. You can see now the result. I'm not showing the whole building, it's very long, but you can see here the black structure of a disk drive. Here you have a gray structure of another disk drive. And now, in order to pick up, lift the pen and put it down, we have a small servo motor over here. Okay? Here you can see the movement of that spiral axle I showed you earlier. And everything has to be very, very precise, and you can see the result. This is a small drawing about maybe 10 centimeters, not more than that. But it's really precise because the discs themselves were very precise when they were born. It's a very high precision technology. And we can take advantage of that without paying money, because all these are things that people throw to the trash. They go out to the electronic junkyard. Okay? Okay. Let me see what happened here. Okay, this is a little more advanced. This is a robot that was built mostly with reused pieces. Of course, we have to buy the leads, but we even reuse some clothing's different. So some students of mine built this and are making money now. This is a robot. Let me show you again. Sorry about this. It's all programmed with a small computer, a microcontroller. It's inside the robot, and it's used to go to parties and entertainment for people. But it was built the most as possible, partially, but the most as possible with reused materials also. That's the main philosophy that we're using with our constructions. Okay, the only part I did not talk about yet is the teaching part. Even though the presentation is about reusing materials, I think it's very important to teach kids with this philosophy, because we also talk about recycling, and it forces them to use their imagination and to be creative. And usually we have some pieces like the disk drives and some hard disk drives and some floppy disk drives that are pretty difficult to unassemble. You have to take a lot of pieces out. They're very small screws. It's pretty difficult. But my philosophy is to work with the kids in electronics and all those things, and then when I think it's necessary, I create the need of using that part of a machine or that program even, because we also program with different program languages. And once the kid or the person, the student, has the need to use it, they are really motivated, and when they start doing very difficult things, it looks easy because they really need it, they want to have it, so they want to learn it. And you find small kids unassembling things that you say, it's really difficult, and they can do it. So that motivates a lot. I think it's very good for learning. They always learn playing. That's a very interesting part. I know Jake knows about this because we think the same thing. And I think it is powerful. Besides, we did it because we have some strange political ideas in our country and we don't have access to materials. Besides that, it's very powerful to help ecology and to help students learning. That completes my speech, my talk. If there are any questions, I feel free. And
thank you so much for the presentation. It was very interesting. I didn't realize there's so much you can do with different parts of things that people would usually throw away.
Neither did I did it. Neither did I.
I do have a question though. May I ask where you learned all this technical information?
Okay, I know it's going to sound strange, but I learned by myself. I started at 5 or 6 years old, very interested about these things. I did study engineering, but I didn't learn all this in engineering. I learned electronics and the technology part. The need for something forces you to think about it. I never thought inside a printer would be so many, you could find so many pieces. And actually, a year ago, I bought a big, huge pack of about 70 printers. And I said, okay, I'll bring some pieces out. I unassembled the first one and it took me about 3 days until I understood how to unassemble it. And you kept on taking pieces outside. You said, how did somebody put all those pieces inside this small printer? I couldn't believe it. But I learned by myself, and I learned a lot teaching also. That is very important.
So may I ask what age are your students, and is there like a recommended age that you would give for people to start inventing with these kind of materials?
in overall, not at the same time, not now, but in overall, we start with 5 years old, and there's no limit. As always, Jake says, we have the students that, well, I knew Jake when I started. I went to the first time to firefighting, the robot contest. And I was curious about the ages, and he said, okay, you have kids from 5 up to kids to 80 or something like that. That was something like his response. There's no limit. Usually they start at 7 or 8. Usually they stop, most of them, about 15 or 16, because they start thinking about other different things, you know, going out and the parties and that. Now, every once in a time, we do have students that keep on going during years, and they get up to 35, 30. They even work on this. I must say it, thanks to our teaching, because first they have to think a lot. They have to really process information and solve the problems. And besides that, they find that they can do it. If we look at the technology from the outside and from far away, you see, wow, that's a good technology. When you start understanding it and working with it, and especially unassembling, not only because when you unassemble, you not only get the pieces, you also get, how did somebody think about doing it, and how did they do it? And that also teaches a lot. It also teaches me every time I assemble any equipment. So we keep on learning on life, Jake, do we?
Is there any special tools for anyone who wants to start working from home? Is there anything that they need to know before, or anything that they should have to start inventing with this?
Well, I had it written down on paper. I didn't have time to read my paper, but yes, the printers, the laser printers are the easiest of all. They are the easiest. I think the whole thing could be done with one Phillips screwdriver, medium size. Now, sometimes you get different pieces, but you don't need special material, the special tools. So, unless you go to hard disks where you use, it's not so special, but it's a little stranger. It's a screwdriver with a special form, and it's called torque. Torque. The measures go from T6 or T5, that's the size of the torque. And disk drives, the bigger one was a very, very old disk drive, was about torque 20 or 25. So if you buy a set of torques from 20 or 15 down to 6, you could almost assemble almost any disk drive. Floppy drives are a little more difficult, and they're a little dangerous because it's a metal case and you can get cut. So I don't recommend that for children. The old disk drives are aluminum. They don't have much thin metal, so that could be okay. And by the way, the older that they are, the disk drives, the better they are. They're more strong in the motors, and they're easier to unassemble.
Ah, okay. So
Of course, you use pliers and probably other screwdrivers, but no special materials. Now, if you want to recover electronic things, of course, you need a solder to unsolder things. We don't recommend that for small kids. We always ask the small kids to be attended by attended or assisted, I don't remember how you say it, by their parents. But disk drives are pretty safe. They don't have dangerous metals in that thing.
Okay. So if anyone had something that they would like to donate, is there any way that they could reach you in order to donate a printer or an old electronic?
Well, I suppose Jake's has my, somebody in gift has my information, my cell phone or my WhatsApp or my email. And we even go and pick it up if somebody calls us, but we don't find it so easy here in Argentina. Mostly you have to buy these things, but very, very inexpensive. We don't still have centers where the people go and they throw it to the trash. That's the bad thing. And sometimes I cannot go around there looking at the trash, looking for things. I've done it some, if it's a very nice machine, you know, nobody's looking at me and they take it out. But it would be better if somebody calls me. I can even go and pick it up. We have no problem here in Argentina.
Awesome. Okay, so they should probably reach out to the Global Invention Field Trip Gmail, and then they can contact you from there. For any students that want to start with disassembling and reassembling, and they already have the materials, are there any resources that you recommend to help them learn how to do these kind of things?
Well, of course, there's internet, but part of my business here in Argentina is teaching. So before this quarantine we're living, I have an institute. The kids come in here. They don't even have to bring the materials. We give them to them because they're almost for free. But besides that, we build robots. We've been participating in a contest, and we try to give that information to the people. Now, since we are in quarantine, we're not so popular at this moment, but we're giving some classes on the internet. So if they already have the materials, it's easier because we can talk and speak the technical things, and everybody, each one has his tools and his materials. And if they don't have it, I try to send it to them. We clean it the most as possible. They clean it again when they receive it. So we try to keep on going during the quarantine. Much less people, but we try to maintain it.
Wow, that's very cool. I'm just amazed by all the things that you can do with this kind of things at home. I do have one last question though. Would you be willing to mentor any other teachers that want to teach their students how to create different things with recycled materials?
I didn't understand. I'm sorry. I didn't understand.
Would you be willing to mentor any other teachers who want to do the same thing as you're doing and recycling materials to create inventions?
Yes, of course. Yes.
Awesome. Thank you so much for the presentation. I very much enjoyed it. Did anyone else have any questions?
I'm getting ready to take apart an old hard drive when I get home. It's just sitting in the garage, and we'll take it apart and play with it.
Actually, Daniel, if I can add one more thing to what Daniel was talking about. Taking apart is different than breaking apart. And one of the tools he did not mention is a hammer. And you don't want to do that because anyone can take a hammer and smash something into pieces. But what Daniel is doing with his students is they are disassembling it with the same care that it was originally assembled with, and now using all those parts. And it's a whole nother skill of learning how to take things apart. Then they simultaneously now learn how to put things together. It's the same.
In our classrooms in the U.S., we call that deconstructing. So they're deconstructing something to reconstruct something else.
Yes. Very good.
Do I have one more minute, Jake?
Absolutely. Absolutely.
First
I'm
of all,
not the host. Gianna's the host. You have to ask her.
host, may I have 1 more minute?
Yes.
Okay, I forgot an example. And there's a student of mine here and asking me if I can tell you about this example. We had a robot that was competing in a sumo fighting. You know, the sumo, like the Japanese that push themselves, the first robot that throws the other one out is the one that wins. And they invented a mechanism that I was really surprised. Everybody was surprised. They used an old mouse, one of the old ones, the one that has the ball, the little rolling ball inside, and they connected the mouse to the robot in order to know when the robot not only was moving its reels, but also moving. So maybe it could be slipping because the other robot was pushing, and that the robot would think he was moving, but actually he was not moving. So they put the mouse on the back and they read that sensor inside the mouse to know what speed was it moving. Is the speed was accordant to the one that the robot was sending to the wheels, and that way they could know exactly what was happening around them and also inside them. So if they were pushing and the robot was not moving, immediately backwards and go away because somebody was about to push you. You know, those kind of things were invented again with old things like the old mouse. Nobody could believe it when I saw it, but really, really surprising. That's a nice example.
Mm-hmm. Wow, that's a great example. I mean, it's just, you know, it seems as simple as a mouse just to be able to do something like that.
Yes.
I would also like to say that we'd love to invite your students to sign up for the September gift that we have. Miss Julie was talking about that earlier, and I just wanted to let you know.
Okay, thank you very much. Thank you.